Fantastic. Thank you very much. Good morning, and thank you very much indeed for inviting me here. So I'd like to briefly introduce you to the perspective coming from CDBB. That's the Centre for Digital Built Britain, which is based at Cambridge University, and it's a joint venture between one of the UK's government departments and the university. And the thing which has got us started on this journey is a report that came out 2 years ago that you may have come across called Data for the Public Good. This came out from our National Infrastructure Commission and it made 3 high-level recommendations to government. The first one was that we should be moving towards having a national digital twin. And then in order to facilitate that, they suggested that we should put in place an information management framework for the built environment that would effectively enable secure, resilient data sharing. And I'll explain why that's so important later on. And then in order to facilitate that, they also recommended that we should form something they called a Digital Framework Task Group. It's a bit of a mouthful, but really the idea of that was to bring together people from across government and academia and industry so that we could all pull together in the same direction in order to facilitate the information management framework, in order to deliver the national digital twin. So 3 nicely nested recommendations, but quite visionary recommendations. The anticipation is that the national digital twin might take 30 years to build out. However, we would need to demonstrate some real progress and some real benefits within 3 years in order to make the following 27 years worth doing. So this is a key bit of context for us. It's a report which kicked off the whole programme, which we're now calling the National Digital Twin Programme. Another key bit of context is the vision for Digital Built Britain. Now, the Centre for Digital Built Britain, which I do struggle to say, so I'll just call it CDBB now. CDBB are effectively the guardians of this vision in the UK for Digital Built Britain. And they've expressed it in 4 words: design, build, operate and integrate. And so as you're familiar with the terminology of BIM, you'll also recognise that design and build is kind of where BIM largely sits at the moment. And I think BIM has given us a fantastic foundation on which we can build. One of the things that BIM has shown us is just how important information is in the delivery process. We know that information has value, that if we lose information in any handover, then we lose value. So something that BIM has taught us is the central importance and value of information. But clearly it goes beyond that, and we can see that we can use information to unlock more value in the operation and maintenance phase of assets and systems. And so that's really where the terminology of operate comes in. But also the vision goes beyond that to imagine what would happen when we get integration across organisational boundaries and across sector boundaries. And so that's kind of what integrate is. And I guess if we put it in very simple terms, and it's probably oversimplified, you can kind of see design and build as being a little bit of BIM. You can see operate as being digital twins, and you can see integrate as being connected digital twins. But this, in 4 words, describes the overall vision for Digital Built Britain. So I've given 2 bits of context already, the government report that recommended it, the vision for Digital Built Britain. Now what I'd like to do is just give a final bit of context of introducing how we're trying to see infrastructure in order to put in place this national digital twin. So forgive me for these coming slides, they will be very familiar to you. I'm not teaching you to suck eggs, it's just to lay a foundation so that we can tell the story. And I guess what these slides also do is describe the scope that we're looking at, because the National Digital Twin really is focused on the built environment, not other sectors. And maybe that's something that we can explore, is just where the concept of connected digital twins can go beyond the built environment. Anyway, let's do this little story. It starts with transport. We're all very familiar with transport as a sector. And in many ways we can see how it is a complex interconnected system. Even if we look just at rail, that's a complex interconnected system. But then when we consider road and air transport, then we can see it's many complex interconnected systems. We talk about integrated transport, but I think it's not really fair to say that we've got that just yet. Then we can also see the energy sector as a complex interconnected system. And this is going to become more complex and more interconnected as we move towards having prosumers, distributed energy generation, and also we can see with energy that it's connected in to every other sector. So it's connected into transport that we looked at, and will become more so as we move to having electric vehicles. We could say the same for telecoms. It's another one of these sectors which is connected into everything else. It is itself a complex interconnected system. Same is true for water. It's one that we don't pay much attention to nowadays. It's kind of out of sight, but it is certainly very complex and very connected. And so, for example, most energy systems won't work without water. And then finally, and not least, is waste as a complex interconnected system. And I guess at the moment we see this largely as a one-way kind of sector, where we collect waste and we throw it away. As we move towards having more of a circular economy, hopefully we will see this coming back the other way, where we don't see waste as waste, we see it as future resource. And if that's the case, then it will just become more complex and more interconnected. And hopefully we won't call it waste anymore. We'll come up with a better name that indicates that it's all to do with the resources. And so what I've shown there are the 5 key sectors in economic infrastructure. So those are all part of scope. And what I've tried to do, very briefly, is indicate that these are complex interconnected systems. But that's not the end of the story, because we also have social infrastructure, so our hospitals, prisons and schools. And none of these make sense unless they're connected into what we've just talked about. Same is true for residential, commercial and industrial buildings. They don't make sense, they don't work, unless it's connected to those complex interconnected systems. And finally, but not least, there's the interface with the natural environment, which itself is a complex interconnected system. So you can kind of see where I'm going with this. I've kind of layered it up. Each one I've called a complex interconnected system, but the thing is we've connected them all up. So what we end up with in the built environment is a system of systems. Very complex, very interesting that it's emerged. We never designed it as a system. All we did was keep building new assets and keep connecting them in. And so what we have is an emergent system that is immensely complex and immensely important to society. If our infrastructure falls over, then so does society. And there's some quite scary reports in the UK indicating where the timing from the breakdown of infrastructure to the breakdown of social society is much shorter than we would want it to be. So basically, this amazing machine that we've built, this system of systems of infrastructure, is an essential machine to keep society going. In other words, we must keep it going forever. And that means that it doesn't have a life cycle, unlike assets which do have life cycles. And so what I've tried to describe here as a context for the National Digital Twin is something that is essential, but at the moment doesn't really have the kind of tools that we need to help to run it effectively and optimize it. So, key bit of context is this systems-based view of the built environment. I think that we tend in the construction industry to see infrastructure as a series of projects. What I think we should be doing is seeing infrastructure as a system, and then we see the projects as interventions on the system. Now that might sound like I'm just playing with semantics and playing with words, but I think it's a very important and different perspective that then informs what we would want from a national digital twin. So very briefly, 4 key systems points. The first one I've already made. It is a system of systems. The second one is that it's also a system of services, because we can see infrastructure as being a platform for human flourishing. And we're maybe becoming more familiar with the terminology, instead of transport, you look at mobility as a service. I think we can see the whole of infrastructure as a service. So it's important, I think, to see infrastructure as serving society. It's via the services that infrastructure provides that we do that. Then there's the cyber-physical system point. And this is really saying that in infrastructure, we have become very good, I think, at managing physical assets. But we are not yet good at managing digital assets. And we really need to up our capability on the digital side, because digital assets are genuine assets. And when we bring the physical and the digital together, that's when we get smart. And effectively, what we're talking about here in smart infrastructure is bringing the thinking of Industry 4.0 to infrastructure. We could have called it Infrastructure 4.0, but maybe that's too simple. But we do borrow all the thinking of Industry 4.0 and just apply it straight to infrastructure. So the whole concept of it being a cyber-physical system is really important. And then finally, but not least, the sustainable system. Because I've already mentioned that this system of systems must be kept going forever. In other words, it must be sustained. However, at the moment, it's not sustainable. And that doesn't compute. It cannot be sustained forever if it's not sustainable. And so that there's an absolute imperative for us to be turning our infrastructure into being genuinely sustainable. And so therefore, the whole pressure currently towards net zero is incredibly positive. That's a key part of it. But I also think that as we drive towards circular economy and we see that we have a sustainable way of dealing with both energy and matter going across a system boundary, that ends up being key to the long-term sustainability of infrastructure. So 4 systems-based points, which you'll see are all context for the digital twin, which I promise you I am getting to eventually. The final bit of context I'd like to just very briefly talk about is the information value chain, which again is incredibly familiar to you, but I'd like to just run through it very briefly because I think this is key to the definition of the digital twin. So we see data coming in from the environment. It can come in many different forms from many different sources, which could be satellite data, the Twitter fire hose, from IoT, it doesn't matter, it's data. But we have to do something with the data to make it usable. And once we've structured the data and cleansed the data and made the data fit for use, it is still just data. And so the next layer up of sense making, giving it meaning, also gives that data value. It generates insight, and it's clear that insight has greater value than the data from which it was derived. So now we like the idea of insight. That better insight then leads to better decisions, and the better decisions lead to better interventions, and the better interventions can lead to better outcomes. So I think it's very important for us to understand this information value chain in order to make the connection all the way through from data to outcomes. Because we said earlier on that infrastructure exists to provide better outcomes for people. It's a platform for human flourishing. And so I think that as we see this connection between data and outcomes, it means that the work that we do in improving data has real purpose. The purpose is to improve economic, environmental, and social outcomes. But the key thing in the middle of that, the kind of the fulcrum that enables the value to be released, are the decisions. It's the better decisions, faster and cheaper, that deliver the value. And that's what we think it's all about. That's the focus of this. And therefore it becomes a focus for digital twins. So eventually I come to the digital twin itself. Now you'll be familiar with this, and I guess the simple definition of a digital twin being a realistic digital representation of something physical. That kind of starts to get a sense of it. But I think the really key part of the definition is this two-way connection. That a digital twin is connected to the physical twin. You've got data coming one way that then facilitates the generation of better insights to enable better decisions, to enable better interventions, which come back to the physical. It's that two-way connection that makes a digital twin a twin. A dead, separate model is not a digital twin. But what we can now do, obviously, is superpower models by connecting them to real data. What we think in the built environment is that data doesn't have to be real-time data. Sometimes it can be, but it depends on the purpose of the twin. I completely agree with what Peter was saying earlier on, that twins need to be driven by purpose, and that will define the quality of the data that's used, what kind of code you have in the twin. It's all driven by purpose. It must be. And so also the refresh rate of the data is driven by purpose. So for example, if you have a digital twin which is to facilitate better operational decisions, then you might want real-time data with a refresh rate in the millisecond level. However, if you've got a digital twin which is to facilitate better planning or resilience decisions, then the refresh rate might be more appropriate at once a month. And so the refresh rate needs to be determined by the purpose. So we don't think real time should be in the definition of digital twin. Maybe right time would be better. Within the digital twin, we see that it's very important to define what the code is. And so we see digital twins not just being data, but also some kind of code that does something useful with the data. So that could be an analytics engine to make more sense of the data. It could be an optimization engine. It could be a simulation engine. It could be a combination of those things. But within the digital twin, there's some kind of code engine that does something useful with the data. And then the other key thing that we think is part of the digital twin is visualization, to help humans interact with it. And even if it's a closed loop digital twin, where the interventions are driven directly from the code, we still think it's useful for humans to have a porthole into seeing what's happening in the digital twin. But very often, with digital twins in the built environment, one part of that process will be intermediated by humans. And so, for example, it may be that humans need to make the actual decision, which then presses another button that drives the intervention. So I think that visualization is a key part of the digital twin. So we see it consisting of data, the engine code, and visualization. So that's all very nice. The reason why I introduced the whole value chain, information value chain point, was to say that I believe that the digital twin embodies that. And so you can see that value chain: data, insights, decisions, interventions, outcomes. And I think that kind of helps us to demonstrate the value of digital twins in facilitating better decisions to lead to better outcomes. So that's all my definition out the way. I hope that all makes sense. We can have a bit of time later on to discuss it if it doesn't. But I don't think that's where the story ends. Because if we like the idea of digital twins, and we recognise that there will be many different digital twins of different shapes and sizes for different purposes, different scales, different time scales, because a digital twin can apply to an individual asset or a process or a system or a whole sector, many different digital twins. What we might want to do, might want to consider, is the connection between twins. And I think that this is where we can unlock even more value, and something which is very important for us to grasp and to facilitate. So, for example, if we've got the digital twin of the train, we've also got a digital twin of the signalling, also digital twin of the track, doesn't it make sense to share some data between them? It doesn't mean sharing all data, it means sharing a subset of the data, the most relevant data that needs to be shared between. And if that makes sense within the context of an individual sector like rail, then probably it makes sense to be sharing between sectors within transport, so between rail and air and road transport. And if we like the idea of that, then why wouldn't we also be thinking the same thing between whole sectors: energy, transport, water? Because as we described earlier on, in the physical world, these are all connected. The system of systems that I introduced laboriously, I apologise, that system of systems is represented by connected digital twins. And so our definition of the national digital twin is not one massive twin of everything. We don't think that would work. What we're seeing the national digital twin being is an ecosystem of connected twins. And each of those twins would be generated by a use case, purpose, going back to Peter's point, but then the connections between them would also be driven by purpose. And so we see the national digital twin growing organically rather than being a top-down thing. And then what we believe is that then represents much better the ecosystem of assets, which is kind of what our infrastructure is. I described earlier on that it's grown, it's just emerged. We never planned it, it's incredibly important, it just grew, but it grew organically. And we see that we need to mimic that with the national digital twin. And so what we end up with as the cell, the origin of this ecosystem, is effectively a connectable digital twin. And the thing that connects digital twins is data. And therefore, what we have to do in order to enable the national digital twin is facilitate secure, resilient data sharing across organisational boundaries. That becomes our problem statement. We're not trying to build this massive model. All we have to address, I say all we have to address, secure, resilient data sharing. That's the issue. And what we think that then therefore means is that we need a consistent approach to data management. We need consistent data modeling. We need a consistent approach to reference data management. And that's what we have to unlock in order to develop the National Digital Twin. This will lead to all sorts of benefits, which I guess would be very familiar to you. I won't run through these laboriously. If in the conversation we want to go back to them, we can. But we see benefits to society, to the economy, to business. We see that this can potentially open up a whole new market, but it only opens up that whole new market if we agree to the rules. If everyone goes off and does their own thing, that's not connected. So there has to be some coordination work to set the rules of the game, and then the game can be played. And we see this as being absolutely essential. There needs to be some high-level input to set those rules, which will then unlock it all, including the benefits to the environment. So how do we set those rules? What is the approach? And we think that there are two extreme ways of getting this wrong. So the first way we think of getting it wrong is to be very top-down and authoritarian. What we could do is lock some experts in a room to come up with a perfect answer, and then we can impose it on the industry. That's not going to work because the experts probably won't come up with the right answer. They'll take too long to do it, and then when they try to impose it on the industry won't have it. So the top-down method won't work. Also, we think at the other end of the extreme, it won't work to be fully Darwinian. If we let everyone do their own thing, which is by the way, the default option. If we do nothing, everyone will do their own thing. Everyone loves digital twins just now. They're all starting to develop them. They're all doing it in their own way. What we'll end up with is some kind of chaos, and it will be very much more difficult later on to come back and undo the chaos and connect it up. So we think there's a real urgency just now to address these high-level rules. And in these two ways of getting it wrong, we think there's something good. So there's something good in having experts who know what they're talking about, who can see the big picture, and who can kind of work for the public good. There's also something very good about having practitioners who learn by doing and just get on and do something, because then we'll learn more. And so I guess it's obvious, but our model is to try and bring these two things together and try to get the best of both worlds. And so the approach that we're taking in CDBB and for the UK's National Digital Twin Programme is to establish this thing we've called the DT Hub, Digital Twin Hub, and that is for practitioners. It's a collaborative, open community that is intended to share the lessons. It's not a hub for sharing data, it's a hub for sharing lessons about digital twins. And so our founder members within the DT Hub are Heathrow Airport, Sellafield, which is a nuclear power station, Anglian Water, Northumbrian Water, the GLA, which is the London Authority, and also Highways England that runs the UK's major highways network. And we've just opened the doors now to the next tranche of members, which includes Network Rail and the National Grid. And so we have within that major infrastructure owner-operators who are developing digital twins and are very keen to share practice. The idea of the Digital Twin Hub is that it would use that identified best practice firstly to develop guidance and then turn the guidance into standards. And so it's a bottom-up approach to growing guidance style of standards. In parallel to that, we've brought together a number of experts to try and address this issue about what is needed at a high level to unlock consistency of data. And they've been working through this last year. Amazingly, we've found 150 experts to work on this. And we think that they're moving towards some kind of consensus. And that consensus seems to be pointing towards just three things which would be needed at the highest level to generate this consistency. The first thing is what we're calling a foundation data model, which effectively is an upper ontology. And what that would do is enable a consistency in data modeling. The second thing is a national reference data library. And the idea of this is that it would be federated and distributed. So, for example, you would imagine that the authoritative sources for reference data in the energy sector will sit within the energy sector. So we're looking to them to generate their reference data. Likewise for water, but then to bring it together. So the idea is a federated, distributed national reference data library. But that's a mouthful, so we just call it reference data library. And then the final thing is the integration architecture, which basically is the pipework which connects it up. Now that's all theory at the moment. We have to start building it. And the idea for building it is that we would start with a top to bottom slice and try to see how we can get a semantic precision that goes all the way through from upper ontology through taxonomy, including what happens within schema and down to the standards relating to data exchange, but get a top to bottom connection. And we're looking to verify that within the DT hub. So all of that, I think, sounds good. It's nice in theory, but I think the only way that this really works is if we genuinely pull in the same direction. So what we would love to happen is that this DT hub can be open. You know, if there's any of you here who have digital twins and you'd like to come in and share in the DT hub, please come. It's open. That's the whole idea. We can learn and share. And then likewise with the Commons, if you want to get involved in helping to define what this foundation data model might look like so that it actually works, then again, we want your involvement. This is not trying to be a closed small thing. The bigger and more open and more consensus we can make it, the better. So the final thing I wanted to say was just to point towards the Gemini principles. And in many ways I could have started with this because this is where we did start. We recognised that a digital twin, being technology, is amoral. It's neither good nor bad, but it could be used for good or ill. And we do see different approaches to data management across the world. Given that our starting point was data for the public good, we really wanted to begin this journey, which I mentioned as a 30-year journey, with values, and to be guided by values on the journey, so that the national digital twin does end up being a good twin, or a good ecosystem of twins, or an ecosystem of good twins. Anyway, we want it to be good, in which case it really needs values. What we also saw is that over a period of 30 years, technology will change many times. So technology is not persistent, whereas we think values are likely to be more persistent. And so we wanted to get those down. We don't think that they're perfect, but they're a starting point. And again, what we would like to do is engage to kind of see if these values resonate, if they make sense, and therefore hopefully improve them and make them something which is genuinely shared. But as you can see, at the heart of this is purpose and trust and function. And one of the key things I guess I should say on trust is that we see with the National Digital Twin, if the people for whom it is made and you know, for whom the benefit will be greatest, if the people don't trust it, then they will tear it down and they won't get the benefit. So it's absolutely essential that the National Digital Twin is trusted, which we think is a function of security and openness and quality. Anyway, I think I've said enough, and hopefully there's time for a couple of questions. Thank you.
We do have actually a minute or two if you want to ask any questions from the first two presenters.
It's complete and utter stunned silence.
Yeah, maybe one question. I'm a bit confused about the target that you have for the National Digital Twin. So you said first that basically the main and the only prerequisite that is needed is a secure and reliable data exchange, right? And it makes sense. So I get the first goal is to make data from public services or from national infrastructure available to other players, or basically between the players. But is your goal also beyond that you want to build some kind of digital twin really that integrates these data, or that integrates simulation models and so of the infrastructure, or is it mostly really the goal of making available the public domain data?
Yes, that's a very good question. So the basic answer is yes, we do intend to do that. But we see that the place where this matters is probably in the context of cities, because it's in cities that these different sectors meet. And so that means not just in the context of cities, but also things a bit like cities. So, for example, an airport is like a mini city. That's where it becomes really important that there is the integration between data from different sectors, because transport and energy and water and telecoms all meet in a city. And so it's really the city twin which will benefit from having the interoperability between the sector twins. And so I think if it's driven by use case, which we said is kind of a prerequisite, that's what drives this all, then we imagine that a lot of those use cases will come from cities. Does that answer your question? So we're expecting city twins, basically.
You have to be careful what you wish for. This security would be the most important thing. We did research almost 15 years ago. We integrated systems from transportation and energy, and we were able to rank the coal transportation in the US and the importance for the energy production. And we were able to rank the bridges that would be destroyed, would leave 60% of the Americans without energy. So at the moment that this happened, they stopped sharing the data. So you have to be very, very careful when you start putting those things together, because the kinds of analytics that you can do when you have all this data together can be used for good, but for bad too. And people get very, very concerned with that.
Yes, you're exactly right. And so we are building security in from the ground upwards. So on the Digital Framework Task Group that I mentioned, the UK's national security agencies are involved, and they're heavily involved in the development of the approach. Something which I think is really interesting in this, though, is a little expression that they use, which sounds nice. They're saying that obscurity is not security. And so just not knowing what's there isn't better security. What's much better is to know what we have, but then to manage it properly. And I think that there's a little bit of a danger that we think in order for it to be secure, what we need to do is just keep it obscure. And it's not that. But we definitely need to attend to security. And I think that if it's built in from the beginning, security minded in everything that we do, then we can build a secure national digital twin.
Thank you very much, Mark. All right. So